You will find tons of high quality Python tutorials on YouTube. What I want to do different in this Python crash course is teach you Python by keeping in mind the use case of AI. So if you are an AI aspirant who wants to build AI solutions or who wants to learn AI using Python, then this is the right video for you. Python is a general purpose programming language. If I teach you all the features in Python, this tutorial video will easily be 10 hours. I don't want to do that. What I want to do instead is teach you only those parts of Python which are used to build AI. You might be wondering, who am I to give you advice on this? I'm Dhaval. I have 17 plus years of experience working for big tech companies like Bloomberg and Nvidia. Right now, I am the co-founder of Dict Technologies, which is an AI services company. We serve to our clients in US and UAE, and my team of AI engineers uses Python on a daily basis. Whatever I am going to teach you today is based on this real industry experience. On the screen, you are seeing the list of topics that we will be covering in this video. At the end, we will be building an end-to-end project for customer feedback analysis, where we will have a front end in Streamlit, back end using FastAPI. We will be using Gemini models for some of the text analysis, and as a database we'll have SQLite. Let us begin by going over why Python is so popular in the world of AI today. The first reason is simple and readable code syntax. On the screen you are seeing the code for reading a file line by line, both in Java and Python. Tell me, which code is easy to understand? Well, Python. It is more like English. The second reason is rich AI ML ecosystem. If you go to PyPy, which is a portal which contains all the Python packages, you will find more than 800,000 open source packages, and you will find all the major AI ML packages such as PyTorch, TensorFlow, Scikit-learn. Thousands of developers have put in a lot of time in building these open source packages, and the ecosystem is so rich that anything that you want to do in AI, you will find a package in Python for that. And the third reason is strong community and learning resources. There are millions of developers who have spent time in making this ecosystem so rich that you want to explore any package, any concept, you will find a YouTube tutorial, you will find data sets on Kaggle. You have everything that you need to build a solid AI application available for free on internet. Before we install Python, let me address the burning question. Should you learn Python in the age of vibe coding where AI is writing all the code? Well, let me give you 3 reasons why you should have good fundamentals on Python. The first one is AI is writing the code, but you need to understand it. When you deploy the code in production, you are responsible for that code, not AI. So if the code is wrong, inefficient, or insecure, it is your responsibility to fix it. Few weeks back, I was in California talking to my friend who is a manager in Apple. And what he was saying me is, although his developers are using AI to deploy the code, they ask them to review all the code. And if something goes wrong in production, that particular person, the developer, is responsible. They can't pass the blame to AI. Second, if you have strong fundamentals in Python, you can direct AI properly. You can help it in architectural decisions, and you can fix some of the errors or hallucinations that AI is producing. Third, the skill has now shifted from writing all the code by hand to reviewing and orchestrating. Therefore, developers with strong fundamentals in Python who can work with AI can work more productively than those developers who do not know Python at all. With that in mind, let's install Python on your computer. The first step in learning Python is to install it on your local computer. Google download Python. Click on the first link that appears here. Click on this particular standalone installer. You can also try this one. And if you have a different OS, you will choose the selected OS. If you want to use a specific version of Python, let's say 3.13, then you click here. Once you have downloaded it, you simply double click it and just say install now. Make sure you are adding python.exe to your path. In the age of AI, you should not be stuck in installing something. If you face any error, just take help of AI tool And now I'm assuming you have Python installed on your computer. I'm on Windows machine. I'm going to open my command prompt and I will just say Python -- version, which will show me the version of Python that is installed here, 3.14.4. So this confirms that Python is installed okay. We will do our Python code practice via something called Jupyter Notebook, and that you can install by running pip install notebook. Pip is the utility that lets you install different modules of Python which are available on pypy.org. Pypy is a central repository of all the Python libraries. You can see there are 821,000 projects. You name any functionality, for that there will be a Python package. Okay, so we just install the notebook. Now I will create a folder to practice my Python. So here in C code directory, I will create a new folder called Python practice for AI. Okay, and then you can C code and then Python practice. So see, I'm here and now I can say Python -m notebook. So that will launch a notebook, which is an interactive environment where you can run the code. Okay, so let me just quickly show you. So here I'm going to create a folder for my first tutorial, which is data types functions, and when you refresh you will see that folder here, and here you can click on new Python notebook. So now here I can write Python code. See, when I say hello world, it prints it. So this is the Python code that I run. All right, so our setup is complete. The first topic we will look into is data types in Python. So let's give a name to our notebook. So I will say data types and for loop. We'll cover for loop as well. Assume you are a CEO of a company, you are a Mukesh Ambani or you are Sundar Pichai. You want to know the finances of your company. So basic finances are revenue and expenses. Revenue minus expenses is profit, and there is profit margin. Let's say you want to calculate that in Python. How do you do it? Well, so I will create a variable called revenue. Okay, so let's say the revenue of my company is $50 billion. So when you do this in Python, you are creating a variable called revenue. Variable is a container that holds some value. Now here you can press key B, okay, B for Bob, to create a new cell. And this is individual code cell that you can run. So if I do type of revenue, and here you can hit Control Enter, it will say int. Now every variable in Python is an object, and the object can contain any value. It can contain integer, it can contain string, whatever. So Python is a dynamically typed language. It's not statically typed like Java or C++, where let's say you have integer variable and you cannot assign any other value. Here to revenue, I can assign a string also. See, now the type of my revenue becomes string. It has developed this spiritual attitude of non-attachment. Okay, so that's why Python is actually very popular, because it's quite flexible. So without going into our samosa business, let's focus on our revenue. I can have another variable called expenses. So let's say my company is amazing, like Nvidia. My expenses are very less. Okay, and my revenue is $50 billion, expenses is 10. To calculate profit, it is simple, right? Revenue minus expenses, and when you say profit, see, $40 billion is my profit. And if you want to calculate the profit margin, it's a simple math. Margin will be profit divided by revenue. Okay, so if you do margin, see, and pause the video and tell me what will be the type of margin. Well, float. If you have done programming before, float is a data type that holds number with fractions. Okay, whereas these are whole numbers, that's why they are called integer. if the number has fraction, okay, 80.2, 80.3, whatever here is 80.0, then the data type is float. As I said, every variable that you create is an object, and you can see the object ID by typing ID function. Now, I attended Google I/O recently, and they covered for my expenses. So let's say I had an expense on Mexican food, okay? So I will say Mexican food at Dish Dash in Sunnyvale. The food here was awesome, by the way. You can create a string variable like this, and the type of that will be string. This is pretty straightforward. But what is interesting here is you can create string in a different way. So here we use double quote. You can also use single quote, okay? So let's say see, that also works. And this is useful. The combination of single quote, double quote is useful when you had quote within the string. So let's say if I had something like, let me remove this. I would love to have a Mexican food. So see, here there is a single quote and double quote, okay? So for this kind of scenarios, it is useful. If you have more than one line of string, you can declare that string by using triple quotes. So see, triple quote. Now here, I can type multiple lines, okay? Expense for Waymo rental and so on, see? And the type of this variable will be string, and you can also say len. So len is a function which will let you count the characters. So if you count characters, you know, totally it will be 69 characters. It's the length of your string. Now, if you are a Java programmer, you'll be like, why don't you use camel case convention like this, you know, where you have a word and the another word is a capital. Here we are separating two words by underscore, and the reason is in Python there is this style guide called PAP8, okay? So according to PAP8, the variables should be defined using snake case convention. Snake case is basically you have your words in small case and they are separated by underscore. In Jupyter Notebook, you can run a cell by hitting Control Enter, or you can simply click on this. See, this will also execute the cell. To create a new cell, you can click on this plus. If you want to execute all the cells, you can say run all the cells, and it will run it. And this number 18, 19, etc. shows the order of execution in Jupyter Notebook. By this time, you have realized Jupyter Notebook is nothing but an interactive way to run your Python code. You can also create a markdown cell. So let me create a cell above it. And how do I do it? By pressing a key A for apple, okay? And in this, I will change the type of the cell to markdown. And here I can use markdown language. I can say data types tutorial in Python. See, this way you can document these things. So here I want to add one more markdown saying that for naming convention is usually snake case, right? Usually snake case, and refer to this particular guide. So notebook, just like your regular notebook, allows you to make some notes and also allows you to execute the code. Now let's say you, Mr. Sundar Pichai, has analyzed the revenue and expenses of Google for last quarter, but you want to do analysis on more quarters. You have not just one revenue, you have 3 revenues and 3 expenses for quarter 1, quarter 2, quarter 3. How do you store that in Python? Well, you can create 3 variables, but there is a better way called list. And the way list works is you will have a name of the variable, then this bracket, and these are the 3 revenues that you have, okay? So if you do the type, it will say this is a list. And if you want to get the first revenue, you will say 0. So this is the index operator. If you want to get the last, you know, the first element from last, you can do -1. So -1 is 55, then -2. Basically, you are going from reverse, okay? From backward to front, and you can also go from forward to backward, by using this positive index. You can also get a sub list. Okay, let's say I want to get Q2 and Q3 revenue. So that you can do by doing this 1:3. So the indexes in the list, they start with 0. So this one is 0, this one is 1, this one is 2. Now I want to get Q2 and Q3 revenue. So the index I will refer to is 1. Okay, so 1 will include that list in the output, and go all the way till 3, but do not include 3, which means it will go from 1 to 2. So the way this list is stored is, you have this kind of locations. Okay, so this is 0th location, this is 1 location, this is 2nd location, and there is a variable called revenues. Okay, so revenues is a variable, it's an object. It is pointing to this area in memory, which is contiguous memory locations. Okay, and when you say revenues 0, it will give you this, 1 will give you this, revenues 2 will give you this. Len of revenues will give you the length of that particular list. If you refer to an index, let's say 10, we don't have 10 elements, then it will throw an error. All right, now let me create the list for both revenue and expenses. So these are the revenues and expenses I have. Now when I want to print the revenues one by one, you can use something called a for loop. So you can say for revenue in revenues, print revenue. So for loop will take these elements one by one and it will do the operation. In Python, the block is specified by indentation. If it was JavaScript or Java, you will use this kind of brackets. Python doesn't have those brackets. It's all indentation. Okay, this space. So here I can type anything. So I can say print revenues. And by the way, to print revenue, to refer to the revenue variable, you can say this, see, or you can use something called Python format string. So format string starts with F and you can specify a variable inside the string, see, inside the double quote. So now I can say this. Now let's calculate profit margin for each of these quarters. Okay, so this is again Q1, Q2, Q3, revenues and expenses for Q1, Q2 and Q3. I want to calculate margins for each of these 3 quarters. How do I do that? Well, first of all, you need an index so that you can refer to the expenses list as well. And the way you do index is you can say for I in length of revenues. Okay, so what will happen is this I will be, actually you will do I in range actually. Okay, range means it will give you range from 0 till length is 3. So 0 till 2 actually. Okay, so 0, 1 and 2. Okay, so this way you are getting these index variable. And now I can print revenue. See, when I say revenues, it will print the revenues. Similarly, I can print expenses, right? Expenses. And now I can calculate the margin. So I can say margin is equal to revenues, or rather, let me calculate profit first. So revenues minus expenses is the profit, and then margin is nothing but profit and then revenues. Control enter and see, this is the margin for 80% margin for Q1, 50% for Q2, 36.36 for Q3. I want to print this in a good format, so I can use Python format string. I can say margin for, I will just say I. Okay, this is how you refer to a variable inside format string. Whenever you put F in front of double quote, it becomes a format string. Inside the format string, you can refer to a variable. So see, I is a variable and the values will be 0, 1, 2. And to print the value of that variable, you can put this curly bracket, okay, around it. Now here I can say margin, see, margin 0, 1, and 2. Now there are so many decimal places, so you can do formatting by adding colon 0.2f, which means it will print only 2 decimal places. Now you want to say, okay, this is for quarter 1. See, instead of 0, 1, 2, you want to say Q1, Q2, Q3. So see, indexes always starts with 0. So if you want to refer to Q1, it is actually 0 index. So you have to add this +1 here and you can say Q, okay? So now see, margin for Q1 is this, Q2 is this, and Q3 is this. Instead of printing it, if you want to store margins in another list, another Python list, you can do that as well. The way you initialize Python list is by saying this, okay? So let's say margins is my Python list and I want to run this particular for loop, okay? I want to run it. And once margin is calculated, I want to append this to this list. You will use this append method, margins.append, and whatever margin you have calculated in that for loop iteration, you will append it. And here you can just say margins and it will print it. See, now margins are stored in a Python list. One problem that I see with the variables I have created here is these are 2 different lists, okay? And I have to kind of assume that this is Q1, Q2, Q3. What if this list has more values? And it's kind of all manual management. Wouldn't it be good if we had a structure, one object where you can store Q1 revenue and expense, another object where you can store Q2 revenue and expense, Q3 revenue and expense goes into third object, and so on. That would be nice, right? So that is something that you can do using something called dictionary. Dictionary is like a hash map. If you have done Java programming, hash map, okay? And the way you define a dictionary is I will create a variable called revenue and you will just give a key and value. So let's say for first quarter, okay, my revenue is 50 and my expenses is equal to 10. So this is how you create this dictionary, okay? And when you say type, it says dict, okay? Here, by the way, you can do this as well, okay? Both are equally valid. Now, when I want to calculate the margin, or let's say profit for this first quarter, I can say fin revenue. This is how you can refer to this revenue, which is 50 minus fin expenses, and you get, see, this is clear because you are having one object, okay? This is like Q1 object which contains revenue and expenses both. If you want to add a new value right here, you can add that. You can just simply say fin of profit. When I do that, it will create a new key in the fin object, okay? And see, now my fin object, which is quarter 1, looks something like this: revenue, expenses, and profit. You can create a list of such dictionaries, okay? So I can say financials. I have a list and each element is a dictionary type, okay? So this is Q1. And by the way, you can do comments by using this hash sign, okay? So hash sign lets you add comments. So comments are basically code that doesn't get executed. It is for documentation. Now see, I have a list of financials. Now to calculate profit, and let's say add margins in each of this, I can say for fin in financials. So fin object in each iteration will contain Q1, Q2, Q3. So I will say profit is fin revenue minus expenses and fin margin is this. Once this loop is executed, when I print financials, see, financial has revenue, expenses, and margin. Isn't it wonderful? Now I am a very good disciplined Python programmer. I want to know what this object is for. Is it for Q1, Q2, Q3? You can do that by creating something called a nested dictionary. So in nested dictionary, you will have key as Q1 and the value is another dictionary. See, so this is an outer dictionary and the value of each of the element is another dictionary. So Q1, Q2, Q3. And then to iterate over key and value, okay. So to iterate over key and value, you will say for quarter and then data in financials.items. When you do items, basically it will print quarter. See, let me just print it quickly. So you see in each iteration, it is printing Q1. So here is key value, okay, for key value in financials.items. Items is a very convenient method to access the keys and values. So here now you can write your logic. You can say margin is this. And now see, you exactly know what is the margin percentage for each of these quarters. Now someone introduced a bug in my upstream system and now they are throwing this kind of objects at me where the revenue is negative. See, revenue can't be negative. So you can add a check to ignore the revenue, okay? So see, when we write code, we meaning when humans write code, when AI writes code, there will always be bugs, okay? Bugs is the constant of life. So in the code, you need to handle those bugs. So I want to ignore that object where revenue is negative. How do I do that? Well, there is something called if condition. If you are a programmer, once again, if sounds like your childhood friend, you will be very much aware about it. So here I will say if data revenue is less than 0, then you will skip that particular value. So I'm going to skip the value here. And then I will do continue. Continue means it will go to next iteration. It will not execute the code that I'm going to write here. See, this code it will not execute when I say continue. But that will happen only if the revenue is less than 0. If revenue is not less than 0, then we want to do our usual logic of calculating margin. This is how the code looks. Let's run it. See, invalid revenue for Q4 missing. I mean, if I had this invalid revenue here, then it will skip that particular part. To summarize, dictionary is essentially a hash map where you can access the value by using a key. Now let's talk about tuples. So I'm going to change it to this markdown and I will say this discussion is on tuples. So let's say you have RGB values. Okay. Now we all know every color is some combination of RGB. For example, purple. Purple is red 128, green 0 and blue 128. You can define purple color using tuple. So tuple is sort of like a list, see, but in list you use square bracket. Here instead of square bracket you use this other bracket, and then you can do same thing that you were doing with the list where you can access all these elements. But one difference between tuples and list is that tuples are immutable, which means you can't change this value. So if I try to change, see, in a list I can change the value, but here if I try to change the value, it will say that this object does not support item assignment, which means once you have defined tuple, you cannot change it. And it's good. See, purple color by definition means this. I don't want anybody to change it. Okay. So therefore, for this scenario, tuple is ideal to use. And if you want to get individual components of RGB, you can do something like this. R, G, B is equal to purple. And when you print R, see, 128. When you print G, it is 0. When you print blue, it is 128. Now let's say you are an artist. You want to mix two colors, purple and yellow. And the color yellow looks something like this. So how do you mix these two colors? Well, I will create a new variable called mixed, and then I will add purple into yellow. And then divide that, okay, divide that by 2. So let's divide that by 2, and here it will be element number 1, element number 2, okay. And when I say mixed, see, this is the color. Now the color has integer value. See, here we are seeing fractional value, float value, dot 0.5, 0.5, etc. If you want to get the integer value and the floor of this division, you can use double slash. Okay, double slash will give you the floor. Floor is like in 191.5, the floor is 191. Okay, so see, now you get the mix value. This is how you can mix colors in Python. You can download this code by clicking on a link down in the video description. And when you open a notebook, there is a super important section towards the end. It is called exercise. See, if you watch these videos as if you are watching a Netflix movie, that's not gonna work for you. You have to practice along with me. And to practice, you need to work on the exercises, a new problem statement. So I have defined a problem statement here. Please practice it on your own. If you're stuck, take help of any AI tool. Learning coding is like learning cricket. If you want to play cricket, will it work if you continue watching IPL and continue watching Suryavanshi or Kohli playing shots? No, you have to take a bat and go on the field and start playing the cricket, okay? So please start playing this coding cricket game by working on this exercise. I will now explain functions in Python, for which I'm going to create a new folder, refresh, I see functions, create a new Python 3 notebook. Previously, we calculated revenue and margin using simple Python cells. But what if you are getting a file? Let's say you are an executive in the company and your finance team is giving you a file with tons and tons of revenue and expense numbers. Every time doing that revenue minus expense is bit cumbersome. We need something that can modularize our code, and that way is function. The way you define function in Python is by saying def, then the name of the function, let's say calculate margin, and then the input parameters. Revenue and expenses are my input parameters, and below that you can write a code for calculating margin. And then you can say return margin. Now watch what happens when you say calculate margin, and when you say 50 is my revenue, expense is 10. See, it is calculating that. So now it has become sort of like calculator, okay? It's a function in calculator where you can supply any revenue, any margin, and it will calculate it. So this is the way people write modular code, okay? You can also create this kind of variable, revenue and expenses, and pass it to a function. In this function, I am returning one value. You can return multiple values as well. Let's say I want to return both profit and margin. The way I do that is I will give a function calculate profit and margin, and then calculate both of the parameters and return them using comma. Now when you do that, it will return it as a tuple, okay? So let me call this function, see, revenue and expenses, profit comma margin, okay? So when I enter it, so here my profit is this, my margin is this. And if you have captured this thing in a single variable, then that type of that single variable will be a tuple. See, whenever you are saying this, one variable comma another variable, essentially it is a tuple. If you say something like this, that will be a list, okay? So here, this is a common practice when people want to return multiple values in any Python function, they return it as tuple. And then later on, if you want to access first and second value, so first value is your profit, okay? Second value is your margin. Assume you are a programmer in Google and you are looking at a big code base. When I was at Bloomberg, we used to work on a code base which will have millions of lines of code. Navigating through code, understanding that code becomes very difficult. Now, if I have a function like this, how do I know what is the data type of a variable? You know, like my input parameter. How do I know what is the data type of my return value? The function here is very simple, but in real life, you will have huge functions, okay? So in Python, there is no data type, intrinsic data type, because it is a dynamic language, dynamically typed language. But there is something called type hint. So you can give a hint to a programmer who is reading the code, or nowadays AI is reading your code, AI is writing it. So to an AI, you can give it a hint by saying colon after the variable colon and the data type. So you are saying revenue is a float, expenses is a float, okay, and the value that it will return is also a float. The way you specify that is after your bracket is over, you will put this particular arrow and you will say float, okay. So here once again, you are not defining a type. If you assign revenue string value, it's gonna work, but what you're doing is giving a hint, okay. So this thing is called type hint. It is just a hint to a programmer who is reading the code or an AI who is reading the code. Let's look at one other useful functionality. I have this function which is calculating my expenses. So when I went to Google I/O, let's say this was my food expense and this was my Waymo car expense. By the way, Waymo car was awesome, okay. I felt as if the ghost is riding my car. This is fine, but let's say I want to add a new expense, okay. I want to add an expense for my hotel, okay. This was my expense for the hotel. Now this is not going to work because this function takes 3 arguments. So how do I make a function which can take dynamic arguments? One time I can supply 2, one time I can supply 3, and so on. The way you do that is by using this thing called args, okay. So I will define a new function called calculate total expense, and I will say star args. So let me just print args to see what it will do. So here I will just say calculate expense, and see, it is printing it. So it takes that as a tuple. So this type is tuple, and you can supply any number of arguments here. Now to calculate total, you can use this method called sum, okay, or you can run a for loop on it and see. Now let me just remove this. My total expense is 18. I can keep on adding this. So args allow you to pass dynamic number of arguments in your Python function. Now I don't like this function because I don't know what this expense for. Is it for food, bill, etc.? What I like is functions like this, where I can say this is the expense for rent, this is the expense for phone bill. So you have a named argument here, okay, and this looks good. But what if I want to add a new expense here? Well, there is another thing called k-args. So here you will put 2 stars. See, in args you will put 1 star. Here you put 2 stars, and this k-args will be a dictionary. So let's print this first so that you understand what this is. See, it took that as a dictionary, and in a dictionary, if you want to calculate the total, you will iterate through the key and value. The way you do that is for key value in dictionary.items, then you add the total. You ignore key, actually, you just add the total, and you add every value to the total and you compute it. So now what happens is my total expense is this. My total expense for my Waymo car was $20. So now this, you can keep on adding it. All right, and now comes the most important section, folks, which is an exercise. I want you to build the chai bill calculator, okay? You all go to the chai stall, build a calculator and give it to your favorite chai wala. Now let's talk about a very important topic of classes and objects in Python. Classes and objects are used to do something called object-oriented programming, or OOP, in software. If you are appearing for an interview, they will ask you questions on this. So let's understand why classes are needed. So here I have information on 2 employees, Mohan and Fatima, and their salaries. And when you want to calculate their bonus, you can write this kind of function, and this works okay. But what if you have 500 employees? Are you going to create 500 variables like name 1, name 2, name 3, name 500 and so on. Second, you can have more attributes like the department, the age, the email of an employee. Are you going to say email 1, department 1 and so on? That is too cumbersome. You can also have more methods, promote, send email and so on. So all of this information seems like they're scattered. What if we can bundle all of this together into a single entity? We can bundle data and behavior into a single entity, and that entity is called class. The way you define class in Python is you will say class and the name of the class, which is employee here, and then you will have a constructor which is def underscore underscore init. If you have used Java or C++, you might be aware about this constructor concept, which is this is how you initialize the class. And in Java, there is this thing called this. So that same thing in Python is called self. So here I am creating a property in a class. Okay, so classes will have two things, properties and the methods. So this is the first property, and the second one is salary. Okay, so this is how you have initialized it, and the method that you have here is calculate bonus. So calculate bonus, and here you will specify self. So whenever you are defining a method inside a class, it will always take this self as a parameter if the method is going to be associated with the instance. I will explain what I mean by this. And here you will say return self.salary. Let's say you are getting 10% bonus. Okay, so that's it. Now when you are creating an instance of a class, so here let's say I will say employee. The first employee is Mohan. Okay, and Mohan's salary is 80,000. Okay, $80,000. See, this is how you create the first employee. It's so easy. And I can say, okay, let me create this, and I can say employee.name. See, it is Mohan. Employee.salary is 80,000. So this is going to call this constructor, which is init method. Mohan will go in a name, this will go here, and it will assign those values to name and salary, which are the properties or attributes of this class. Now I can call a method called calculate bonus, and see, this is the bonus for Mohan. Okay, you can create another instance. Now you want to create 500 employee instance. It's so easy. Okay, employee 1, employee 2, and this is very intuitive even to a human eye and human brain, right? You have an entity which has all these methods, all these properties. Actually, name and salary are properties, and you have method. You can have additional method. You can have another method called send email. Employee can send email, and you can define the behavior here. Okay, you can have n number of methods. So this class here, this particular thing that you see is called a blueprint. And here what you have done is created an instance. So emp1 is one instance of class, emp2 is another instance of class. It is sort of like I can have a class called human. Okay, and the human class can have, let's say, name, age, all of that. Instead of age, maybe I can take the birth year. I can have it something like this. And when I say get age, you can compute the age. Okay, I'm using the datetime model in Python. All right, now here I can have myself, right? So let's say the world is one instance of human. See, I'm part of humanity. I have 2 eyes, 2 legs, I have certain structure of my brain, and you, the person who is watching the video, is also human. Okay, so individual humans are the instance of the class humanity. So here, let's say this is my name, and I can say get age, and it will get the age for a person, right? Here you can have a different person. For example, Virat Kohli. Okay, what is his birth year, by the way? Okay, I don't know, I'm just going to assume something, and virat dot get age. See, it's a very simple concept. Essentially, you have this class as a blueprint, and then these objects which you're creating are the individual instance of the class, and they can interact. And when you're writing a big code base, creating classes make things easier for you. There is another way to define a class, and that is using a pydantic module. Okay, now you need to install pydantic module, so you can just go here and you can say here pip install pydantic, so that will install the module for you. And let's say you are defining a class for a recipe, so a recipe can have title and calories. So in pydantic, the way it works is you have a class which you derive from a base model, and you will say type hint. Okay, title colon str, title calories colon integer. Now pydantic classes do not have methods, they are just a list of fields. You will be like, you can do this using Python dictionary as well. Well, you can do it, but pydantic classes will enforce the types. Okay, so title can only be string, calories can only be integer. It is the intrinsic behavior of a pydantic class. Okay, so let's say I want to make a dal. By the way, I'm going to cook dal today. My wife is working today, so I make really nice dal fry. So I'm gonna cook that. So now you can create an instance of this pydantic class by saying that title is equal to yellow dal, calories is equal to 280. See, notice the difference between the syntax between your regular class and pydantic class. Okay, now I can say dal.title and it will do that. Now see, title here is a string. Instead of string, if I assign number, what's gonna happen is it's gonna fail. See, validation string. So this way, if you want to create a blueprint of an object where you want to have some kind of type enforcement, then pydantic will help you with that. When we'll look at some of the LLM calls, you will find that having pydantic class will be very useful. And now is the most interesting part, folks. Exercise. You're going to create a YouTube channel class for my own channel and just share the code with me. Maybe I can use it in my real work. Now comes a very interesting part of this tutorial, which is calling LLM. When you're using ChatGPT, you are calling LLM via ChatGPT app. But here I will show you how you can call it programmatically. For this, we are going to use Google Gemini model. Okay, so here we will look into the documentation, and the code is pretty simple. Okay, so I will just copy paste this code here, and you are importing GenAI module from Google, and then you are creating a client. See, this is the class. Okay, and this is the object, and you will say client.models.generate content. And Gemini has different models, okay, 3.5, 3.5 Pro, Flash, and so on. And then you will ask your actual question here. See, if you see all models here, you will see all kind of models. We are using 3.5 Flash. And if you look at the quick start, you need to install Google Gen AI module for this. So let me go to my command prompt here, and you will just say pip install Google Gen AI. You have to install the module, okay? Otherwise you will get an error. The second thing you need to do is you need to set up your API key. So here you can just say Gemini API key and just go to this aistudio.google.com using your Google account login, and then you can create an API key. So just click on API key. It will create the key, this like long looking string for you. And here you can create a project if you don't have a project. Okay, so just create a project here and just say this is the API key for my Python tutorial. Create a key, and this is the API key, this long looking string. You click on this to copy the key, and what we will do is here in this folder, you will create a file called .env. Okay, and in this .env file, let me open with Notepad++, you will say Google API key equal to copy paste that key. Okay, so just to summarize, you are in this folder and here you have created this .env. I don't know why this is not visible here, but here you have .env with Google API key mention. Okay, and this is like your password, so make sure you are not sharing this API key with anyone else. Google offers generous free credits, so for this tutorial the credit should be okay. If it goes above the limit, maybe you can spend some money and buy some credits. That way you can run your code. Now the way you load that API key is by using a module called .env. So we are going to install .env module. Anytime throughout this tutorial, if I don't show you, just use your common sense and install the module, use AI tools to find help. Okay, now when you call this method from .env module, what's going to happen is it is going to load that key into an environment variable, and this Gemini API internally uses that particular environment variable. So now when I run it, what's going to happen is it's going to make a call to Gemini 3.5 Flash. It is going to ask it a very important question that I have pasted here. And see, wonderful, you just wrote the code to call LLM programmatically. Now, what if I'm building an app which asks for ingredients, the cuisine, Italian, Mexican, etc., the diet, and it will generate a recipe for me? Wouldn't that be something amazing? So let's do that. So here, I'm going to define a function called generate recipe, where it will take a list of ingredients, tomatoes, potatoes, wheat flour, whatever. And then cuisine can be Italian, Mexican, Indian, and diet can be vegetarian, vegan, etc. In this function, I'm going to write a doc string. So doc string is a documentation for this function. So at the beginning of the function, you are saying, okay, what is the purpose of this function? What can cuisine be? What can diet be? And so on. And then in LLM, you will pass in a prompt. So the prompt is a format string. You're saying generate food recipe using these ingredients. Okay. So ingredients is a list. And when you want to create a string out of a list, you use this kind of operation. So let me just quickly show you so that you understand. When I have ingredient list like this, when I do this, you're simply getting a string, comma separator string with the ingredients. Okay. So here I'm saying generate a food recipe using this ingredients. Cuisine is whatever is the cuisine, diet is that diet. And the remaining code is same as what we wrote before. You are going to call Gemini model. Okay. So let's do Control Enter so that it's executed. And then we will generate a recipe. Folks, I'm going to cook this today. Okay. I have tomatoes, lentils, onion, jeera. I'm going to cook the dal. Okay, jeera tomato dal. Yes, see, if you want to do pretty printing, you can just say print here. Isn't this amazing, folks? Here I can have a different recipe. So let me just copy paste this thing here. And instead of Indian, let's say I want Mexican food, which is vegan. I have ingredients as corn, black beans, avocado, and it's generated a recipe for vegan Mexican corn and bean salad. This is so amazing. Now let's do one thing. Let's create a functional app using this particular code. So what I will do now is open my Visual Studio Code. If you don't have Visual Studio Code, install it. It is a very popular free IDE that lets you write code. So far we are using Jupyter Notebook, but that is good for learning purpose. If you're building any production grade application with multiple files, etc., then you will use VS Code or PyCharm or any other editor. So let's open a folder here called Python Practice AI. Okay. And here I have this call LLM notebook. Now I have the Claude Code extension. So I have the subscription of Claude Code, and I'm going to ask that check this and create a Streamlit app that can generate recipes for me. Now, why am I showing vibe coding? Well, because vibe coding has become a new normal nowadays. If you get hired as a Python programmer, you will be using vibe coding. So I want to show you what's happening in the industry today. Streamlit, by the way, is a way to create a UI application. Okay, so see here what it did is it created this thing called recipe app. It used the notebook that we created, by the way. Okay, so it used this particular notebook that we had, and it created this recipe app. And the recipe app looks something like this, where you have Streamlit as STC. You have all this beautiful code. And let me just run this code first so that you understand what's going on. To run it from VS Code, I will start the view and terminal. You start it and then go to that particular directory. And here you can say Python hem streamlit run recipe app.py. Now what it will do is it will open a browser window, and look at this, folks. Your UI application is ready. See, in just one prompt we created a UI app. So here you will specify all the ingredients. Tell me what kind of food you want to eat. I will say aloo, peas, wheat flour. I hope you're getting where I'm going with this. The cuisine is Indian, the diet is vegetarian, generate a recipe. And it gave the error because 2.0 Flash is not available. So we need to use whatever model we have in this. See, I want to use this Flash model somehow. See, vibe coding is not perfect. See, this shows that vibe coding is not perfect. You need to have understanding of your code is doing. Otherwise, if you treat it like a black box, then you'll have a problem, because this AI can always make mistakes. See, it generated a recipe, aloo matar paratha. I hope it created a recipe for samosa. But this is so powerful. You have a front end working where you can give the input and you can generate a recipe. Okay, so Streamlit, folks, is a way to create a quick UI. Data scientists and AI engineers use it to quickly demo what they have built to business managers. And when it comes to production, people will use things like React or any other standard framework. If you want to learn AI engineering in a most practical way by building production grade AI applications, then check out our live AI engineering cohort. We have classes on weekends via live Zoom, and we teach all the necessary concepts, including cloud technology, by using a simple analogy and most practical applications. The cohort first student had amazing experience. One of the students, Sai Ganesh, got a job midway through the cohort by demoing the project that he built during the cohort. Then we had another student, Mehboob Ali, who built a SaaS agentic application for CPMAI exam prep. Students are having a very good experience. You can check the status of this cohort live. As of this recording, we have the ongoing cohort. Therefore, you have to join the wait list, but just check it out using the link provided in the video description below. Let us now talk about error handling. Why is it important? Because when you're calling LLM in production, you can always get errors, and you need to know how to handle them. Here I have the code for our revenue expense scenario, and watch this. Revenue is 0. Now, if you are not completely sleeping during your math class in your school days, you would know that you cannot divide any number by 0. It's basically an undefined operation. So when you run this, you will get 0 division error. But what exactly is this? See, this is called program is crashed. Program crashed. It was not able to handle it. It's like give up totally. And this is the error that it threw. This is called traceback. Okay. And the way you read it is from bottom to top. So here, this is the error that you got. You got that error at this exact line. Okay. So this is called exception. Your Python program is throwing an exception, and the class of the exception is 0 division error. There are many other such errors. For example, I have revenue array, and if I index to the 10th element, I will get index error. Let's say if I try to convert this number to integer, it works. But if I have something like this, it's gonna again throw this error called value error. So there are all these different errors, okay, value error, index error, 0 division error, and so on. And the way you handle these errors is by catching them. Let's say you are running a program in production which is calculating the profit using revenues and margins for 10,000 companies. And for one of the companies, let's say there is a data error, revenue is 0. You don't want to crash your program. You want to handle that one specific company and move on. So the way you do that kind of handling is, let me define revenue and expense once again. You will put it in try except block. Okay. So after try, you will have your actual logic, and then you will say except 0 division error. You can hit tab and it will autocomplete. So if the instruction, okay, any instruction in try block throws 0 division error, then program will not crash. It will come here, and here you can do whatever handling you want to do. Right now, I will just print that revenue is 0, and let's run this code now and see what happens. See, revenue is 0, can't calculate margin, skipping. The program did not crash. You did not see this kind of red error. For 0 division, people usually write this kind of safe margin function. They say, okay, revenue and expense divide. Okay, you're calculating margin. You can expect this kind of error. And now when you run it, see, for the first one, it was a valid operation. For the second one, we had divide by 0. So you got none as a margin. You can also store this particular error in an object. So for example, here I'm having a value error, and then that value error I can store in an object by saying as e. And when I do that, you will get details of that error. So here the e object contains this detail, invalid literal for end with base 10, 20. Now, why does it matter when you are building LLM apps? Well, we had this generate recipe function, correct? But when I'm running this function, things can go wrong. Let's say my API key is not valid, or Google servers are having some issue. This model is not available. I will get an error, and I can't leave the code open like this. I need to put some guardrails and defenses. So here I can say try. Okay, let's put this whole thing in a try block, and then accept exception as e. And here, see, once again, you can handle it the way you would like to. You know, it's just code. You can write any code here. But essentially, if exception is happening, here I am saying could not generate a recipe. And this response text, you can put it here. And you can also check if response has a text or not. Let's say if this text is coming blank due to whatever reason, in that case, I will return this kind of string. So now, when I run this code, and let's say if there is a problem with API key, etc., it will not crash. It will show you a appropriate message. So let's try it out. See, we have this env file from which it is loading the environment key. I'm just going to rename it to some gibberish, okay? And let's see what happens now. So let me run this code. It should not work because it is not able to load your API key now, okay? And by the way, I need to put this code from .env. Okay, I need to put this code, control enter. See, Okay, invalid syntax. Okay, this is invalid syntax. Control enter. And see, sorry, I couldn't generate a recipe. And see here, it crashed actually. Why? Because my client was created here. So let me do it here. I mean, usually you'll create client outside, but just for demonstration purpose, I'm creating a client in try block. And see, sorry, couldn't generate a recipe. No API key was provided. You did not see that red error, which means program did not crash. It went here. Okay, and through this E, it provided you the exact error details. And here is the exercise for you. What I want is you to incorporate error handling in your chai stall code. Okay, so read this carefully. If necessary, feel free to use AI, but I would recommend you write the code first and then use AI. And by practicing this exercise, you will make your fundamentals clear on error handling. Let's make sure you have renamed your file to .env. As a next step, we are going to create now a chatbot with memory. So I have created this particular folder and I will now go to the folder there and create a new notebook. I made a simple call to Gemini saying that my name is Dhaval, remember it. And it is saying I will remember that. Okay, it made me a promise. And then I'm asking what is my name, and watch this. See, it's like Ghazni, it forgot what was my name. Why is this happening? Because when you're calling LLM directly using this generate content method, it doesn't store previous conversation. It doesn't have memory. Now we learned about list in Python. So using the list, we can add that memory, we can add that context. What I have done here is created a list called conversation where we'll keep the conversation history. And this is the function. Okay, so this function will take a new user input every time. It will keep on adding to this particular list. And this is the convention that they use in LLM where you say role is user, parts, whatever. And this code is same as before, but in the contents, instead of passing a string, you are passing the conversation, which is the list actually. Okay, so you keep on doing that, and then towards the end, see, you are adding the new message into conversation. So now I will say chat, hi, my name is Dhaval, please remember it. Chat is not defined because I did not run it. Control enter, and okay, it got it. Now I can say here, what is my name? And see, your name is Dhaval. Now it's remembering it. Why? Because when you ask this second question, in the second question, the first question is also appended. So it's like you are having ChatGPT conversation and it remembers the syntax. It remembers what you asked it before because it has this concept of memory. So here you build a memory using a simple Python list, folks. And if you are becoming AI engineer, etc., you will notice that you will be adding memory into whatever AI systems that you're building. And let's print whatever you have in conversation. See, conversation is a global array. So see here, you had my name is Dhaval. Hello Dhaval, got it. I'll remember your name. See, user is saying this, model is saying this. User is saying this, model is saying this. This is like ChatGPT. User is asking question, ChatGPT is answering it. User is asking the question, ChatGPT is answering it. I will create Streamlit app for this too. I will say using the code in chatbot memory. Okay, create a Streamlit app. See, my IIT Stanford engineer is working for me. This is a junior engineer. I give it any work and it will write code just like that. Perfect. It created this app.py actually. It created this app.py. Let me run it. So Python you can directly run Streamlit as well, by the way. So Streamlit, do I have Streamlit? Okay, maybe not. So Python m Streamlit run app.py, and see chatbot with memory. Who invented transcendental meditation? So see, when you're asking this question, it's gonna call Gemini and see, it's founded by this. When did he pass away? So when I say he, actually it remembers that you're talking about Maharishi Mahesh Yogi. See, you just created something like ChatGPT, you are asking question, it is remembering the context using the memory, and it is storing all of those responses into this session state conversation. Basically, that's just a Python list. All right, folks, now is the time for exercise. You will build a movie recommendation buddy that remembers your taste. Let us now look at how do you get structured output from LLM. Here I am asking it for a recipe with calorie count, and it generated that. But the response.text is this big string. And if I'm building an app which, let's say, just extracts the calorie out of it and shows it on some dashboard, then how do I do it? Because Gen AI can generate different kind of outputs. It might say 340 kcal, it might say 340 calories, and so on. I can use regular expression to extract it, but that doesn't sound like a good way. There should be a better way. And that way is you can instruct LLM to generate a JSON response. So maybe I change my query and I change my prompt and say return only JSON with these keys: title, calories, prep, time, minutes. Okay. And when I do that, the response should be well-formed JSON object, okay, which it did. And it has this prefix, code JSON. So what happens is when you try to load the JSON, so there is this method called JSON.loadString, okay, response.text. What it does is it will convert a string. This is a string, okay. It will convert that into a dictionary. But when I do that, I will get this error. Why? Because of this extra thing I have. See, if it was just only this, it would not have given me any error. See, let me just show you. If I had something like only this without JSON, okay, if I do that, it gives me a nice dictionary object. But here I got an error because of this extra preamble that I have. Now, of course, you can do some processing. You can strip that kind of data, JSON, remove prefix, remove, all of that will work. But we need a better and more robust way. And for that, you will use Pydantic classes. Remember, we learned about Pydantic classes before. So you will create the Pydantic class for the structure or the shape that you want in the output, in the LLM output. So I will say the output that LLM is producing will have title, which is a string. It will have ingredients, which is a list of strings, and so on. And then you call your Gemini. Okay, I'm calling Gemini. And in that, see, I'm passing this one extra parameter. I'm saying config. So in the config, I have generated content config, where the structure type is JSON and the schema is this class recipe. So now Gemini LLM knows that it has to produce output which adheres to this particular schema. So let's call this and print response.txt. So I get that, but this is still a string. If you want a dictionary, you just say, or a class, Pydantic class, you'll say response.pass and you get it. See, this is so good. I can store it in a recipe object and I can say recipe.calories. Okay, calories. See, the output is structured this way. All right, so just to summarize, what we did here is we gave it a Pydantic class so that it can generate the output in this particular schema. And now if you are creating a system where you have a downstream component which is consuming the output created by LLM and doing further processing on it, then doing it this way, doing it by using structured output will be much more beneficial. And as usual, you have the exercise here. When you're writing any code, you will almost always work with some kind of files on the disk. So let's look at how do you do file handling in Python. I'm going to write a file first. And the way you do that is you will say with open. Let's say I want to create a file with a joke in it. Okay. So you give a name of the file in the open argument and the mode. So here I am using the write mode. Okay. If you are using read mode, then it is R. And then you will say as F. So when you do this, it will use something called a context manager and open a file handle. Okay. File pointer. Now here I can say f.write, which will write a line to that file, and I can have multiple lines written like that. Okay. /n means a new line. Okay. Here's a joke. Control enter. And when I look at this, see joke.text is created, and I can pull that joke here. And as you can see, my memory is so bad. How bad is it? How bad is what? So it is writing to that particular file successfully. Now, when you do with, you don't have to do f.close because the context manager will take care of closing the file handle once you are done with it. If you do something like this, joke.txt, this particular thing, okay, and if you do f.write, etc., okay, then later on you have to do f.close. And sometimes people forget to close the handle. It might not be good. That's why it's better to use this with, which is a context manager. It will manage the context. Now the file is written. Let's try to read the file. So I will say with open read mode. Okay, read mode as F. And now see, if I do f.read lines, it will read all the lines, in a single list. See, this is the single list that you have. What you can do as an option is for line in F, this will print the lines one by one. Third option is you can say content is equal to f.read, and that will get you entire content. All right. So now let's look at one other file which I have here. It is meeting.txt. Let's say I have meeting transcript. I want to use LLM to summarize it, to get action item and so on. So this is the meeting in some kind of manufacturing company. So I'm going to open this file first here. See, you have opened it in read mode, and here the document is now a string which is containing the meeting transcript. You can then use Gemini model, and you can say that in prompt, here is a meeting transcript. Okay, this meeting transcript, see document, this is the variable we are passing here. Summarize it in 3 short bullet points. Okay, this meeting transcript can be very long. I want a quick summary in 3 short bullet points. See, it got me the summary. And then you can write that summary back to another file. You can say summary.txt in write mode and summary saved. So now here at the same location where I have my meeting.txt, I will find summary. See, these are the 3 action items. You might have 1 hour, 2 hour long meeting where people keep on talking. At the end, what you want to know is what is the action item? What is the quick summary? Using LLM, you can get that. You can also write content to file in a JSON format. So here I have dictionary for my recipe, and I'm saying after opening a file, I'm saying json.dump recipe into the file, see, and indent to. So now when I open the file, this is what I will see. See recipe.json, see, you see a proper JSON object. Okay, JSON is like dictionary, you see, and that has made possible because you're using json.dump, giving your recipe and giving the file handle. And the same thing, if you want to read back, you can say json.load. Okay, json.dump, json.load. So when you do it, this will be a dictionary. All right, and there you go. We have an exercise, folks. I'm pretty sure you all are sincere students. You are working on exercises. You will find all the code in the video description below. Majority of the production grade systems will have dependency on getting data from somewhere outside by calling API. Okay, for example, here I have this portal that lets you get the exchange rate. So right now, let's say USD to INR, US dollar to INR is around 95. I want to get the latest rate. This portal will allow you to do that for free. Okay, so see, this is how it returns the rates in a JSON object. And the URL that you type in is this. See, if you type in this URL and let's say I want conversion from USD to INR, it will give you both the rates. I think it's using euro. Okay, euro to INR and then euro to USD. If you want USD to INR, then you use this kind of API. So this is the HTTP call. Okay, it is using HTTP protocol. It is just a URL, folks. When you call that URL, it will return you the data in this kind of JSON object. Okay, so this is the JSON object it is returning, and it is telling me USD as of June 2nd, 2026 is 95 rupees. Okay, in most of the production grade applications, you will see some kind of usage of this type of HTTP calls. Now I called it in a browser. How do I call it from my Python program? Well, for that you need to install this module called request. Just do pip install request, and once the module is installed, you can import request here and then specify your URL, and you will say request.get. Okay, so the response that you got, okay, let me store it in a response. Let's see what exactly is the response. It is of some class, and by the way, if you want to see the members of that class, you can call dir, and that will show you all the members. So here there is this member called JSON. Okay, I'm interested in that. Status code, I am interested in that. So let's first call the JSON method. So I will say response.json. Wonderful. See, it's giving me the currency exchange rate, and then a response.status code is 200 means success. Okay, 404 means not found. You might have seen this 404 not found errors on the website. So you will get all those status codes. You check the status code and then you do the data processing. I can store this JSON object in data and then see data rates. Okay, and INR. This will give you the exact conversion rate. You can supply the parameters in a params parameter. See, initially I had it in the URL itself, and this looks little messy, question mark. It's little bit cryptic. But if you want a clean format, you can say from USD to INR to euro actually. Okay, and see, this is how you can print that. Now, folks, whenever we are calling any API, we have to do error handling because things can go wrong. Their server might be down. Okay, network issues. So you will see in most of the production code, there will always be a check on the response. You will check if the status code is 200. 200 means it's successful. Then you extract the information. Otherwise, you catch the exception, you print a message, whatever you want to do, you can do it in the error handling portion. Now, how do we use this in any AI application? See, large language models have knowledge cutoff. They would not know, for example, the latest USD to INR rate. So I want to give some math problem to LLM. Say I have this many USD, how much it will be INR, okay? Or some question on my stock investment. So let's try this exercise, okay? So I'm going to create the same, okay, copy paste Gemini model, and I will also get USD to INR rate in this particular thing. Now the prompt that I want to give is this. See, I have 200 NVIDIA stocks. See, Isn't that amazing? You must be a rich person if you have NVIDIA stocks today. By the way, I used to work for NVIDIA back in 2007 when the stock price was less than $1. And don't ask me if I have stocks or not, because if I had stocks, I would be retired on an island. I'll be still making videos, by the way, because I love it. But just assume I never worked in NVIDIA. Let's not invoke the memories of selling NVIDIA back in 2007 at a very less price. Anyways, so you have 200 NVIDIA stocks. Let's assume, let's have a good dream. And the price is this. How much money will I get in Indian rupees? See, the stock price is in dollar. I want to get the appreciation, how much money I made in Indian rupees. And then I'm saying today's USD to INR conversion rate is this. See, if I did not have this API call, LLM would not be able to figure out the current rate because it has a knowledge cutoff date. It doesn't know about latest information. Okay, so let's try this out. Control Enter. Isn't this amazing? Number of stocks is 200. Price per stock is this. So total USD value is $43,000. And if you convert that to INR, it is close to 40 lakh maybe. Yeah, 40 lakh rupees of NVIDIA stocks, folks. Isn't that cool? Now, a quick note on API keys. Many times, these data providers require you to pass API key. The platform that we used, okay, Frankfurter, doesn't require you to pass API key, but most of the platforms will require you to pass API key, in which case you can pass it using this parameter. All right, and here is the exercise that you can find at the end of the notebook. When we use Frankfurter, we use the API created by somebody else. What if I want to create my own API? For that, we will use extremely popular framework in Python called FastAPI. To install it, run this command in your command prompt. I have already run it. It's installed. I will go to my VS Code, and there I have this new directory called FastAPI. Here I will create a Python file, call it main.py. I'm not using Jupyter Notebook because running FastAPI is convenient through VS Code. So that's the reason I'm using VS Code here. Here you can import FastAPI class, okay, and app is equal to FastAPI. Then you can say app.get. Let's write a hello world program, return hello world, okay, and then you can run it from here. So let's open the terminal window. Here I cd'd into FastAPI, and then I will call it FastAPI dev. This is how you run the program, but this is not working due to some reason. The other way to run it is uv run FastAPI dev main.py. Okay, it is running the server at this particular location. So I will copy paste this link, put it in my browser, and see, this is the first server that I have created. Wonderful, right? Now, this is a very simple code. It just returns you an object. It is a get call. By the way, other than get, you can have post call also, okay, where let's say you want to update data in the backend. For that, you will use post call. I have changed my message in Hindi. And now let me create an endpoint. So you have APIs. In APIs, you can have multiple functions. Just like in calculator, you can have multiple functions. So this is your root message, okay? But let's say I want to create an API endpoint or a functionality to calculate margin. How do I do that? So there you will do app.get/margin, okay? See, /margin. So in the URL, you will type /margin, and it will take revenue and expense as an input. And here, along with the margin, let me also return profit. Okay, so this is it. So when I save it, it is automatically restarting the server. Here, when I go to the root, okay, without any slash, it will give me the default message. My default message is whatever I have in my root. But if I say margin, okay, so let's do margin. So slash margin. Now the way you pass your revenue and expenses is by doing this. So you will say question mark revenue equal to this and expenses equal to this. See, my profit is 2000 and my margin percentage is 40.0. Now let's build something interesting. How about we build an endpoint which can do sentiment analysis? So I have a customer review. I will pass it, and using Gemini model or any other LLM, it will say whether it's a positive, negative, or neutral. Okay, so let's do that. For this, I will be using the app.post and I will supply the review. Now review, I will use Pydantic model. Okay, so review is a string, and by the way, Pydantic model helps you validate your request and response. That is the reason I'm passing. Otherwise it has text. You can pass text also, but if you're using Pydantic, you can do the validation. And the sentiment, which is the output. Okay, so review is the input, sentiment is the output. It will have label with whether it's positive, negative, whatever, and it will also have a score. Let us call same Gemini model, and here I will use 3.5 flash actually, and I will say find the sentiment of this customer review, review.text. Okay, so customer review is coming as an input, and in the output, see, response schema. Remember the last session on the Pydantic, we said that you can enforce structured output by using this kind of response schema, which is your Pydantic class. So sentiment I'm supplying as an output. So when Gemini generates the output, it will adhere to this particular schema. It will have label and score. And you would like to return the parsed response. Okay, so that's it. Now, how do you call it? Well, you can use an application called Postman to post a review, because here this review is something, it's inconvenient to pass it in the URL. Many times when you're calling these APIs, you have a big object that you want to supply, right? So that is inconvenient. So for that, you can use Postman, or we can use the Swagger documents. Okay, so see, FastAPI gives you this inbuilt functionality where you type in your URL and then say /docs, and it will give you the documentation of your API. So I have three methods. One is the root, margin, and sentiment. If you look at sentiment here, okay, say this is the schema, text string, this is the schema, correct? Response is string. So now I will say try it out. So when I say try it out, here I can pass my string. Okay, I have this review for the restaurant I went to, and I will say execute. See, the response is negative. The sentiment is negative with a score 2. Isn't this amazing? You just built your first endpoint, API endpoint that can do sentiment analysis using free Gemini model. If you're targeting AI engineer career, you will most likely be building this kind of APIs using FastAPI. Now, these APIs can be called from the front end, from the UI directly, or it can be called from some other backend program. The next topic is databases. When you look at enterprise applications, most of the data lives in some kind of a database, and you will have a need of interacting with this database, reading the records, writing records to database, and so on. In the files tutorial, we wrote our recipe to a JSON file. But imagine you are working on some kind of software for restaurants where you get thousands and thousands of reviews. You can't save things in JSON file, right? Because they will pile up. Also, when you want to do some analytics on top of these reviews, like how many are negative, how many are positive, and so on, doing it on file becomes a little bit cumbersome. Whereas with databases, it's super easy. I have created this database folder, and here I will add a new Python file, and we are going to use this lightweight database called SQLite. So this SQLite is a very, very lightweight database. It will essentially save your data into like a local file, but you can do database operations on top of it. It's a relational database. We are going to use a module called SQLite 3. So you can import that. And if you don't have that module installed, I will show you a way to install it via Jupyter cell. So you can say pip install SQLite 3, and you have this exclamation mark at the very beginning. So that will run that. Okay, so let's see how to install this one. Looks like this is not the right way. Okay, you do not need to install SQLite because it comes pre-installed with Python as a standard library. Okay, I did not know that. So we don't need to have that cell. SQLite is already imported. Now let's create a database called shopdb. Okay, so here I will say SQLite3.connect. Now when I say shop.db, I do not have this database, but if it does not exist, then it will create it. And I can save return value in a variable called connection. And then you have to do connection.cursor. This is just a convention, folks. Don't worry, I will show you how to use this. And now you can say database is ready. So control enter. Database is ready. You see shop.db file appeared here. This database is empty right now. In a database, you will typically have tables. So let's say when you are looking at a database for your store, grocery store, you will have tables such as products, customers, transactions, and so on. Table stores one kind of entity. Here we are going to create a table for storing reviews. Okay, we are using this database for storing customer reviews, and the way you do that is you will use this cursor object. You will say cursor.execute, and you will run a SQL query. I hope you know fundamentals of SQL. If not, you can refer to any SQL tutorial. Here we are creating a table if not exist, reviews, and these are the 4 columns that this table will have. So control enter. Looks like it worked okay. Now we are going to add some rows into it, and the way you do that is, once again, you will do cursor.execute and write a SQL query. To insert a row, you can say insert into reviews. These are the 3 columns. See, text, label, and score. ID, it will assign it automatically. And the exact value of text, label, and score is this. See, this is the review. The biryani was amazing. Label is positive, score is 5. Okay, so let's execute this. Okay, it inserted the record. And after the record is inserted, you have to do something called commit. If you have learned SQL and database fundamentals, you'll understand commit will actually persist the records to a physical disk, to a database. What if I want to insert multiple reviews in one shot? Okay, let's say I have all these reviews, 4 different reviews. So in that case, I can call another function called execute many, and here you will say insert into reviews this, values this, and just supply the Python list that you created. And after your query, you will execute commit. Okay, all these 4 reviews are inserted. Now let's try reading these reviews. So I will say cursor.execute. How do we read all the reviews? Well, by using select query. You will say select star from reviews, and then rows is going to be cursor.fetch all. Then you can do for row in rows, print row. See, we inserted those 5 reviews, and those 5 reviews, now we are reading it back. Say you want to read all the negative reviews and work on improvements. So for that, you will execute another query with where clause. You're saying where label is equal to negative. This is how the syntax works. And then when you run it, you are only seeing the negative reviews. See, we have 2 negative reviews, right? 1 and 2. And here we said select this from reviews where label equal to negative. This is the syntax. And once you are done dealing with this database, you will say connection.close. This will release all the resources associated with that database. And it's a good practice to kind of clean up the things. You know, it's like I'm eating something, and if I see something spilled over, I would clean it up. So this will do the necessary cleanup, and it will release the resources. You saw how easy it is to interact with databases in Python. That is one of the reasons why Python is so popular. The API, everything, it's like so easy and intuitive. As usual, towards the end, you will find an exercise, and I'm pretty sure you all are sincere students. You will work on this exercise. Now is the time that we tie everything that we have learned together and build this project called Customer Feedback Analyzer. The way this will work is, let's say you have a restaurant, you're getting a lot of Google reviews on it. You want to do analysis of those reviews. So you will take those reviews here. Every line is one review. You will then click on Analyze button, and it will make a call to our backend. And in the backend, it will use Gemini API to perform the sentiment analysis. And it will show you results like this. This review is negative, then theme, is delivery. Here the theme is price, and so on. You also get the aggregate summary. For example, there are total 4 reviews. Average score is 2.5. Percentage of positive is 25%. And then when you click on Save Report button, it will save that particular report to a database. So this way, this is a complete project with front-end, back-end, and SQLite. And here, of course, in the back-end, you are calling LLM. Okay, so you're making a call to LLM, which is Gemini in our case, to send a review. So review will be sent as an input. LLM returns the analysis of that review, which is positive, negative, score, and so on. And then FastAPI backend will save it to SQLite database whenever you say save to database. Now in front end, we are using Streamlit because it helps you develop things quickly. When it comes to production, people do not use Streamlit usually. They use something called React or any other JavaScript framework. You can build a front end in React using vibe coding very easily. So if you want to try it out, you can try it out that as well. But as far as this project is concerned, we will stick to Streamlit. To get started, I have created this folder called Project Feedback Analyzer. And to keep things clean, in the left panel, I will open that folder so that I don't want to see other files. So here, I will open this particular folder so that I have a clean file view. See, I don't have anything other than the empty folder. Now let me add a file for sample reviews. Okay, so sample reviews.txt, and I have some reviews. Every line is one review. Okay, so this is what we have. Now we are going to use something called a virtual environment for this project. Why is virtual environment important? Let me explain by drawing this diagram. So let's say you have this project for feedback analysis, okay? And you deploy this project on some computer in the cloud, okay? So this is a computer or a machine in the cloud environment. When I was at Bloomberg, this problem used to happen. So it's very relevant. We had a server called EQServe, okay? And in this server, somebody will deploy a program. Let's say this is my program A, and this program depends on Python's request module, let's say 1.0, that is a version. Now on this server, there will be a global Python installation. So let's say Python is installed here globally, okay? This is the global Python installation. And you have all the packages. Let's say you have pandas. Okay, pandas you have 1.2. Then you have request you have 1.0, and so on. You have all the modules. So now this program is conveniently using this module and it is working okay. But what used to happen is somebody else will deploy program B, okay? And see, this module, for example, request is not part of the program. It is outside in the global directory somewhere. Now, program B requires, let's say, request 2.0. So they need a different version of this request module. What will happen is somebody will go and they will upgrade this version to 2.0. But when they do that, this program might break, because between 1.0 and 2.0 there might be a backward incompatible change. When this program was tested in dev environment or alpha, it was tested using request 1.0 module. Now all of a sudden somebody is updating the dependency and things may break. Okay, it's not necessary they will break all the time, but there will be occasions where things will break, this program will crash or show an error and so on. So this used to happen at Bloomberg when I was working, when we were having a common servers between multiple teams, or even within one team. There can be multiple programs. So to solve this problem, what you do is you use something called virtual environment, and generic term is containerization. There's Docker and things like that. So Docker and virtual environment is kind of similar concept. They are actually different concept, but conceptually you want to include everything that you need, all the dependencies in your one package. So what we started doing at Bloomberg is we came up with this virtual environment or containerized environment, where let's say you have global Python installation. Okay, you have a couple of modules. So we don't care what those modules are. When we ship this program A, okay, so let's say this is program A. Program A's code, right? Your business logic. But other than that, we will have complete Python environment. So there will be Python, there will be other libraries like request, pandas, everything is packaged into this artifact. So when you deploy A, it goes as a complete package. Whatever program needs, everything is present in that container. So you don't have to look outside. Outside, if somebody upgrades something, you are not affected. And whatever you have in your package, program B cannot use it. So program B will have similarly their own code for the business logic, right? This is their own code. And they will have their own Python, pandas, etc. Now, one obvious question you will have in mind is, this is a redundant space that you're occupying. Well, that is true, but space is very cheap nowadays. Okay. So what is important is program should work. Program should not break. Functionality of your software should stay intact. And this kind of packaging approach gives you that expected outcome. So for our project, for analyzing feedback from customers, what we are going to do is a virtual environment where we will have all the Python libraries, or everything that we need in one container. And for this, you need to install UV Python package manager. So go here, based on your operating system, install it. I have Windows, so I open my PowerShell. See, copy here. Okay. Go to a PowerShell, Windows PowerShell, copy paste this, run it, and it will install your UV. Once UV is installed, you need to init this directory. And the way you do that is you will go to view, open the terminal, and here just say UV init. So it will initialize your UV Python environment, and you will get files such as pyproject.toml. Now in this file, you will mention all your dependencies. What are the packages that I need? Well, I need all these packages. So you will do that. Okay. It also created python.version, which is 3.12, and so on. Now that you have necessary dependencies in pyproject.toml, you will run a command called uvsync. So what's going to happen is, it has installed all these libraries locally in this directory called .venv. Okay. So here, if you look at libraries, see, you see all the, let's say you need FastAPI. Okay. See FastAPI, you have FastAPI here. And not only that, all the dependencies of FastAPI. So let's say FastAPI needs 10 other libraries. They are also installed. So this way, in this .venv environment, I have everything, all the libraries, everything that I need for this particular project. this kind of approach gives you reproducibility, like a predictable output. And to initiate the virtual environment, because see, if I run Python right now, right? See, it will use the global Python version, which is 3.14 point whatever, right? But what I want is, I want to use whatever is in my virtual environment. So for doing that, let me go, I don't like PowerShell, by the way, so I'm going to go to normal command prompt here, and here I will initiate my virtual environment. And the way you do that is you will say venv scripts activate, and you see this, now my Python environment is activated. So now whatever command I run, see right now it is saying 3.12.13 because it is referring to the local Python here. It is referring to local libraries here only when you are inside the virtual environment. Now I will first work on the backend. Backend will take the review as an input, and it will use Gemini's API to mark it as positive, negative, score it, etc. We have done this kind of coding before, so we are not writing everything from scratch. All right, so let's create this file. I'm going to create this file here, api.py, where I will import certain necessary modules. So you all know we are going to use GenAI from Google's Gemini model and FastAPI. This is something we have done before. Now to define an endpoint, you will do something like this. Okay, so here you are creating an endpoint called /analyze where you will pass a review. Now what exactly is this review? We need to define a pydantic class for it, and my pydantic class is pretty simple. In the review you are passing a text, so whoever is calling this backend, it can be user interface UI, it can be another backend program. Whoever is calling this particular backend program will pass text review. Okay, and it will be this class, and this is pydantic. We have seen this before. Let me define another class, which is analysis. So analysis is something that Gemini will return. It will return whether the review is positive, negative, neutral, what is the score, theme, and so on. And look at this AI, it doesn't have patience. It just wants to write the code for me. Okay, so this is how it should look like. I think, is this correct? Yes, this is correct. Let me put one more indentation here. And here you can do 3.5 as well. But anyways, this code is something we have seen before. You are saying analyze this customer review. Label must be positive, negative. Score must be this. Theme must be this. And here you are specifying the output type. It is JSON, and it should adhere to this schema. So you are guiding LLM to produce output in this format. What is the format? The object that LLM returns should have label, score, and theme, and this should be the data type. Okay, so this is what you specify here when you say response schema is this analysis class. Okay, so this backend is ready. I would like to run that, and to run that you will just say FastAPI run api.py. Okay, so it is running it at this location 8000. So let me click on that, open. Okay, failed to load, hold on. So you will generally say 127.0.0.1. That's how you do it. And see, right now there is no like default endpoint, but if you do docs, you will be able to see the Swagger docs, which will show you the endpoint. So the endpoint that I have is analyze function, and it takes the review as an input string. I would like to try it out, and to try it out, you will just say try it out. Pretty simple. And here I'm going to pass the actual review and execute it. So now it is calling my backend, and the response is negative, score is 2, theme is delivery. See, cold food again, of course it's a negative review. This is the third time the delivery was slow. So the theme is delivery, the score is 2. Okay, so this is how you test your backend. You can test your backend using a tool called Postman also. Okay, this will help you make HTTP calls to the backend. Anyways, we tested it here. It looks good. Let's now write the front end. So for front end, I will create another file called app.py, and here I will put all that Streamlit code. So I used vibe coding to write this code. Nowadays for writing front end, I'm not writing it by hand. It's pretty easy using vibe coding approach. And here what we are doing is this. See, let's ignore this database part for initially. Okay, so let me just comment it out. So the API URL is this, right? We saw that here. This is my URL and /analyze, that is my endpoint. Okay, and when we get the reviews, okay, so reviews will be posted in this kind of input box. And when somebody clicks on analyze button, see analyze button here, then what happens is you take all the reviews and you create a list out of it. So here it's a list where every element is one review, and you run a for loop on it. Okay, and for each review you will call the backend. So request.post text that review, and when you get the response back, you will append it to results list. Okay, and that result list you will show it in the front end. Okay, so once again folks, I have not written this code. This is totally vibe coded. For front end, vibe coding works like a charm. You don't have to manually type this in, but of course you need to understand what it is doing. So here this is a button click. Here this is how you get text from the input, and then here is how you run the for loop. Every iteration you are calling the backend. For each review you get a response. Responses are aggregated in results, and then results you will show it as a table using the code below. Okay, now let's think about the database part of it. So database is going to be a separate file. So let me just database.py, and in this file, once again, it's a simple SQLite database, feedback.db. We just had a session on SQLite, so you know how to create a database. Okay, create the feedback table first when you are running the program for the first time. So the feedback table will have ID, review, label, score, and theme. So whatever a response you are getting here, see, let me show you. So let's say you click on analyze, you are getting all this response, and when you say save report or save database, I change the name of the button. When you say save database, it will save this particular response, which is review, label, score, theme, and all these aggregate details. Okay, it will save it to this feedback table. So here you have all of it, and when you say save results, you are running insert SQL. Okay, and when you say load history, so I will show you the load history feature in a minute. Okay, so here my backend is already running. Here you see the backend is already running. I will now create another shell here, and here I'm going to start my front end. So how do you do it? Streamlit run app.py. Okay, I was getting initdb not imported from database because I did not have this saved. Now I have it saved. There is initdb, and that's what I am calling. So let's run this again. I'm going to give you the sample reviews file. So let me try only 3 reviews and analyze. Now when I call analyze, when I click on analyze button, watch again. So the analyze, what it will do is it will take the reviews from the front end, it will run the for loop, and it will say request.post API URL. What is API URL? Well, this 127.0.0.1.8,000 analyze. Okay, and it analyzed it, and you got all these wonderful reviews. Hooray! This is so amazing. You have your label, score, quality, you have your summary, and so on. I don't have any saved history, but when I say save to database, it is going to call my database, and see I have this 3 results saved. I can try a few more as well. So I'm going to try 3 new reviews and see, I got this. I can again save it to a database. And now in my saved history, I have this 6. So if you're a restaurant owner, you can bulk download your Google reviews. For example, you can format it into this kind of text file where one line is one review. You can give it to this tool, and this tool will give you very nice analytics. This is a real project, folks. Somebody who is a restaurant owner, or not just restaurant owner, any type of business owner who is processing reviews will find this project useful. So this is a really useful business project that you have just built. And if you look at this feedback.db, and by the way, you have to install the extension to view the SQLite database. You might not be able to view it directly. You have to go to extension and just say SQLite view or something like that, and install this particular extension. Then only you will be able to see this kind of view. But anyways, so here, see, you have review, label, score, everything. Folks, whenever you have this kind of project, it is necessary that you have a good readme.md. And nowadays with AI, you can do this easily. I have Cloud Code extension installed here in my VS Code. That's why I'm seeing all these icons. And here I can say that fill content in readme.md, and it will analyze your project and it will add all the details. If something is missing, you can manually edit it. And once readme is created, you should upload this project to GitHub. If you don't know GitHub, you can find some nice tutorials and upload this project to GitHub, add it to your portfolio. It's going to be very valuable in your job search process and to boost your online credibility. So see, it created my readme.md. If you click on this, you will see the preview. So see, this is how the preview looks like. You see in the right hand side, it's a nice MD file. Alright, so this was a pretty good project because you covered database, you covered backend using FastAPI, you made calls to LLMs, you had a front end in Streamlit, you use Python's virtual environment, you use for loop, Pydantic. We covered all the topics, most of the topics that we learned throughout this tutorial, and build this end-to-end project. As a next step, what I want you to do is write a nice LinkedIn post and just describe your learning lessons from this project. You can link your GitHub repository here. LinkedIn is very important to boost your online credibility. You can tag me, you can tag Code Basics. We have a huge following. When we engage on your post, you are going to get some visibility as well. So make sure you are writing a LinkedIn post for this project with some modifications and tag me and Code Basics. All right, that's it. If you have any questions, please post in the comment box below. If you want to continue your learning journey, refer to this Agentic AI crash course. Thank you very much for watching.